is a brain or the circuit board out of a carrier heater, house heater. Is currently out of commission here on Christmas Eve, and I'm trying to figure out what's going on with it. I ran a little test that it says you can run on it to have it test the different components in the whole system, and everything seems to pass that component test. But when you operate it normally, it comes up with the error 13 or an error 33. The LED blinks the certain code. So I started checking things manually myself, and it seems like every time you try to operate the furnace normally, the blower motor never turns on. So I'm thinking something in here is not turning it on. Now the thing that's weird about that is when I run the component test, it turns the blower motor on for a few seconds like it says it should, but when I try to run the furnace normally, it doesn't turn the blower motor on at all. And the blower motor is good because I tested it and it works fine. So either the relay in here that is controls the blower motor is not working properly. I can hear it clicking here, but it must not be working properly, or there's maybe something burnt up on the circuit board and it doesn't have enough current or something because the board's burnt. I put a meter on it, and the output for the heat, and that's right here where my finger is pointing, when the blower motor is supposed to kick in, and it jumped up to about 45 volts, and then it quickly went down again. So to me that's telling me there's something going bad with this here. So I'm going to take this apart quick and just see if there's anything here that I can fix or repair my own here. But in the part number for this one here, this is out of a carrier. I don't know if I said that, but this is a HK42FZ011, and you can get these for, I don't know, somewhere between $200 for one that will work just like this, but it doesn't look nothing like this. Or you could get one that looks just like this for like $550 or whatever. So that would be your choice, and whatever way you want to go on that. This just comes right out, this plastic piece just pops right out the back. It's got little fingers that holds it in there, and we'll be able to see if there's anything burnt in the back of the board as soon as I can pop this thing off here. It's got two little tabs on the side right here. There we go. Alright, I can see a burnt spot right here already. You can see that it's dark around that, and that looks like it is out by a relay or something. Let me see if I can get the rest of this out. Oh, there we go. Just falls right up. Looks like it. Hopefully. Unless I'm missing something. Oh yeah, these little things are holding the board in too. There we go. Alright, that's what that looks like. So, where was it? It was burnt right here. You can see it's discolored there on that one pin, and that is this this one right here. I have to change my glasses here so I can see what the heck I'm looking at here. This is a Otter and Brumfield. So yeah, we need to look into this component right here. And I just happened to touch these resistors right here. These are usually get pretty warm, these here, and usually it's burnt around these resistors. And if you watch this, I can move that one really easy. So that's not, that one's tighter, but this one's really easy. So yeah, that one, let me get the old magnifying glass on there one time. Oh, gotta move the right one. Yeah, the looks like it's heated up enough to where it broke the pad, or just the adhesive of the pad is no longer sticking to the circuit board, but it is attached to the trace. For how long, who knows? But so we can probably leave that, or we can just jump a wire across from there to there. Jump a wire from here to here, since that's where it connects, just to make it a stronger, just to kind of eliminate that trace. So if it does break on the trace there, then we don't care. And then we can do the same here. It just goes from here to here. So we could just solder these right together. And this way we don't have to worry about the trace breaking and then causing us problems. I noticed also that this point right here, which is on another one of these smaller relays, that looks like it got kind of warm. Because it lifted the pad off the board, but it's still connected to the trace. So what I want to do is, besides just fixing this, because the furnace is at somebody else's house, of course, I would just solder this up and take it over there and try it, and you know, if it doesn't work, I'd have to bring it back and blah blah blah. But I think what I want to do is I want to pop this relay out right here and just test it right here to see if it works okay. But I want to test it out of the circuit so I don't damage anything on here. And then maybe I'll test this one too. Take this one out and test this one too, since it got a little warm on there. So that's what I'm going to do now, is take those out, and I'll fix these here too. Alright, I got a little setup here just to test these relays. I have the two relays I told you out of the board. I have 1 meter just to show you the voltage that's coming from my power supply, which I got it set at like 21 volts, 22 volts, whatever. Because this one says it's rated, that one says it's rated at 22 volts. Get this in the picture here. This one here, this little one here, says it's 24 volts. This meter here is only there for the sound. I got it on continuity. So I got it hooked up to there, and I was testing this to make sure that it works. So that little relay works. So I was, because this was the right here, the one that I told you, it looked like it lifted the pad, but it was still connected pretty good. But I was just curious because this relay goes to the heat side, and the other relay on here goes to the cool side for when you have the AC going. Okay, so I'm going to take these off and we're going to connect them to the other one. And I'll put these on the switch, which is just normally open. So it's open right now. As soon as I connect these, it should close. So I'll just connect. This is the coil down here in the bottom. And then we should hear the continuity again. Excuse me. Alright, and I'm just going to leave the same voltage. You can hear it clicking, but I can't hear no continuity on the meter. Now, to me, that tells me this is a bad relay. Like the contacts are not there anymore or something. Because it should be just like this one here, where we energize the coil and it makes the connection, gives us continuity, then it breaks it. So every time we hit this, it should be together, giving us the beep on the meter, and we're not getting nothing. So that, I believe, could be the problem, because that relay, it says right here BLWR, and that means blower. So this is the one that would turn the blower on, and the blower motor is not coming on during its normal cycle. You can see that it burned the board pretty good there, so it was definitely heated up. That pin was not even, it was just barely soldered on, as you see in the picture, but apparently it seems like it's internal here. I did look up the prices for these type here, and this particular one is about, I don't know, $6.50 or something at DigiKey. This only has 4 pins on it. This one here has 5 pins on it, and this one's like $7.50. But I'm not thinking this one's bad, because it's not burnt or anything. And this one here controls it, whether it's gonna blow cold or blow hot, meaning it's going to, this is the coil, these two right here, it's going to energize. This is the common, so the power, whatever you connect to it, is going through here, and then it's going to connect to one of these two right here. So this one is the heat. This pin is the heat that goes out here, and this one is the cool for your air conditioning. It goes out here. So it depends on what you have your furnace set on. It'll depend on which way this one's connected to. So we want it on heat right now, so we want it to go out here. And you can see that these are connected together, actually. So we energize this, and our signal is supposed to come through here and go into here and through this common to connect to the heat right here, and then give us power to our blower motor, which connects right there. But that's not happening because we're not getting a connection between these 2 points right here on this relay, this one and this one here. So that would be that's what seems like to be our problem here. So I'll have to order one of these. It's gonna be a couple days, so hopefully the weather gets nicer. It's gonna, well, it's gonna, because it's next week. It's supposed to be in the 50s. All right, that's all I got for right now. I won't ramble on. But you see now I checked the relays. We got one bad. I'll get that ordered. We'll get it put back in and we'll try it, and hopefully that fixes it. I did forget to mention that, I don't know if some of you noticed it or not, but down here on these 2 resistors, I strengthened the pads that these resistors were attached to because they were lifting off. So I just ran a wire from that pad of the resistor to the next pad closest to it that it went to, just to kind of strengthen up the trace a little bit, so nothing happens later on to those. I just wanted to add that in there, just so if you notice that, you didn't look at it and say, what the heck's going on there? I did take this other one out, the one that has 5 pins on it, just to test it to make sure that it was good, because you know it would have ate through me if I didn't do that. And I wanted to test this one again just to make sure I wasn't doing something wrong, but there isn't much you can do wrong when you're just testing that. And I took this one and I went like that a couple times, and now listen. Now it beeps. So it was stuck on the inside, and when I did that, it actually broke it loose. Up there, it's not doing it. Now it's doing it. So there's definitely something broke on the inside. It's not getting a good contact. So we still need to replace this one, but I just thought I'd throw that in there and show you that that's a way. These are sealed, that's why I did that. That's why I banged on it. I'd have to tear this one completely apart just to get it to look on the inside. And so I banged it just to see if it would break loose whatever was locked up in there. And there is something locked up. So it's not consistent, so yeah, we'll still replace this, but I just wanted to show you that. So I tore it apart anyway. I thought it was going to be worse than this. This is what it looks like on the inside. I accidentally broke the side off there. This piece is stuck down in there. But you can see the smoke and discoloration on there. And down inside there, right there where you can see the brown looking, or the lighter color, that's smoke and whatever that must have went up at one time. But it seemed like there was something stuck in the contacts when it blew up or something. It must have jammed something in there. But I put it together now, and I can't get it to fail. It works every time now, but of course I've got to get a new one anyway, because you know, we can't put this in there like this. But yeah, watch now. Works every time now. I mean, I was tearing it apart, and I dumped some stuff out of there, but I'm sure most of it got in there because of me, but I think there was something stuck in there also. because now it works every time. No problem at all. I went ahead and I put this broken relay back in the board, and I used some black tape just to cover up the hole that I punched in the side of it. But I don't recommend this. But it took a week for me to get the new parts, and it's winter, so I wanted to get them some heat in their house. So since I was able to get this one cleaned out from the inside from being burnt up, and it worked consistently afterwards, I put it back in there, and it worked for the week that we waited for the parts. Like I said, I don't recommend doing this because this is a 30 amp relay, so there's a lot of current going through this, or there could be a lot of current going through this, and if this happens to arc and start a fire on the inside of this relay, the reason these are sealed is so a fire can't happen on the inside. It just automatically extinguishes itself. But since I broke the corner out of that, air can get to it, and it can create a fire, starting the whole circuit board on fire. So that's why I don't recommend putting it back in there. But if you do that, you're doing it under your own will. I am not responsible for it. But we got the new parts, so now I got the board back out, and I'm going to replace both of these. And both of these are sealed, so now we don't have to worry about that. So we should be good. Just to run over this real quick one more time. The way I got a couple pictures here. The reason why this happened, that I can see, is this was the fault of the homeowner, and they told me that they were going to change the filter, but they kept forgetting, and everybody does. Okay, well, just because your filter says it's supposed to be in there for 3 months or a month or a year, like some of the thick 4-inch ones, 5 and 6-inch ones, doesn't mean that you can put your filter in there and then just forget about it for the whole year. Here's a picture of a year one that's supposed to be in there a year. That could last a year, but it depends on what your household is like. If you're doing construction in there, how many animals you got, how dirty your house is, blah blah blah. So this filter here was disgustingly dirty because of all the factors above that I just mentioned, and it just was never a thought to the homeowner that this was all collecting in the furnace filter, and that's what caused this board to burn up like this, because the fan started getting hotter because it was working harder trying to pull the air, the cold air, through the cold air vent and push it up through the furnace to heat the house. So that makes more current go through this relay right here, and this relay gets hot, and that's what burnt up the contacts on the inside and burnt up the plastic on the inside, and that's what probably broke off on the inside, was a little chip of plastic from being so hot that it dropped right in the way of the contact, so the contact couldn't open and close all the way. Actually, so it couldn't close all the way because it didn't work, so it couldn't turn on the blower. So once I cleaned that out, now it could close all the way, and it worked just fine. But unfortunately, I broke this taking it apart and blah blah blah. But so I guess the full thing, the most important thing about this is don't just throw your filters in your furnace and forget about them for however long it says on the furnace. I would check them monthly, until you can determine what is a good amount of time that you can go with before you need to change it. So maybe a year filter needs to be changed every month anyway, or every 3 months, or every 6 months. So yeah, all right, enough of that blah blah blah. So maybe you need to stop this video and go check your filter now so you don't burn up your board. Good point, right? Okay. All right, here we are over at the furnace. I got the board in down there on the bottom, all wired up. I turned the heat up so it would kick on when I flip this switch right here. So let's see if everything works. Let's see if it kicks on. Over here, some noise first. Lights blinking on the board. Now this fan should be kicking on here any second. The exhaust fan. If the blower motor kicks on, we're in business. But there's a sequence that every furnace goes through, so we have to wait for that to happen. You can see it's blinking a code right now, but that code will get cleared if you just let it sit and run for a second. There it goes, and now our fan just kicked in. Now once that fan blows, then we should get up in here is our combustion chamber. So we're going to get our igniter to light up here on the next click. And it should start glowing in there. There it is, it's glowing. And then the gas should kick in any second. There's the gas. Now, if everything else is okay, that means we should hear our blower motor kick in here in a second. And that's going to be down in here, which we can't see, and I unfortunately don't have a flashlight on me at the second, but we'll be able to hear it if it kicks in. If not, the whole thing should shut down. And when it shuts down, it'll give us a blinking LED there with a code. There it goes. I heard the relay click. And now I hear the fan blowing. Alright. That looks like a winner. Everything is operating the way it should. Alright. Looks like we can close this baby up and get on to the next project. Alright. We'll see you in the next one.